right? So 10, yesterday was mastery, so no homework on the mastery day. 10.1.2 is today's. I will give you the 2 days, even though you probably don't need it, so that it won't be due until Thursday. So that's the only other homework that's actually due this week. I was chatting with one of your classmates today who said it's actually not, because they asked me, did you get the homework or the test graded? And I said, yeah, absolutely not. I spent 2 hours on Zoom last night. Because if you don't remember, about a year ago, you were getting Zoom calls from your advisor that you didn't know yet, from Phoenix, to talk about what Phoenix really is and make sure that you wanted to come here. Some of you might be thinking back to that call saying, I should have jumped off this train right then. No, I'm joking. We're glad that you all decided to come here. So, all of us 7th grade teachers in the evenings right now are not only grading papers and lesson planning and making worksheets, we're also meeting with people on Zoom. So I got 2 more Zoom calls tonight. I don't know if I'm going to get your Chapter 9 test graded. But, like one of your classmates said, that's no problem because then you don't have revisions to do. Right? So until I get it graded, you don't need to worry about it. Maddie? Oh yeah, lottery already happened. All the kids are polled. They're assigned to advisory groups and we're making calls. Yep.
Are there any kids that
80, some, 85, 87, I don't know. I mean, however many are supposed to be in a Phoenix class.
I'd
Do what?
I'd like to see that list because I might know some people.
It's kind of the list that we have has too much information on it for us to just show it to you. We could probably trim that information off and then.
Say, you could just give a list of names because I might know some people that are.
Nope, not right now. Sorry, we got math to do. So, on your 10.1.2 worksheet. Sorry, this is not going to turn into let's talk about next year because I only have like 35 minutes left to do math. And honestly, it's probably not enough time for what we need to do. So, the first thing I want you to do with your team. Sorry, if 10.1.1 is done, turn it in. I should give you that chance. 10.1.1, turn it in. If it's done, in the bin. Oh, if you turned it in yesterday, I have it. They're just in my folder, still to be graded. So, and also Chapter 8 Mastery Revisions, a couple of you turned that in. I need to grade those. So like Nolan and Grant, I have your 10.1.1s. So hopefully things are correct. Same with Gus. Hopefully your answers are correct. Otherwise, you're going to be getting it back. Well, you're not supposed to turn them in until we check them, so. Hey, so we're going to put away any past homeworks. The only thing we should have out right now is 10.1.2. So before we dive in, let's look at the little math notes box on the front of your homework, because then there's only one problem from class in here. Today what we're talking about is surface area and volume of a cylinder. Now, on here is only volume of a cylinder because surface area, the math notes box, is on 10.1.3, but these have not come back from the copy center yet. So if you're dying to see the surface area of a cylinder, I bet there's this website that you could go type in anything you want and get some results about how to do things. Really, I was referencing Google. But yeah, if you want to Google surface area of a cylinder, or now it's in the video, or it's in the next lesson. This is in 10.1.3. If you just scroll in the ebook, it is there. Nolan?
It's also on the sheet of paper that you gave us all with like formulas and stuff.
When did I give that to you?
Yeah, we didn't get that.
You didn't get that.
We gave it to me.
You sure? You sure you're not remembering the court?
Yeah, I'm positive of that because I just didn't remember.
I'd like one of those papers.
I don't know what he's talking about, so we'll circle back to that. All right, so.
Circle cylinder.
But it involves circles.
I know.
It involves 15 centimeters of
All right.
circles.
One thing we got to get straight with all of us right now. Big B, meaning uppercase, right? Capital B. Big B is now what we start using, like for the rest of your math career, to mean the area of the base of the cylinder, or any three-dimensional shape. So big B, you should make a note or highlight things or something to make it obvious that the area of the base, that is what we call big B. Also seems like a pretty great rapper name, right? Big B. Hey, Big B.
Oh, the house.
So, for a cylinder, to find the area, and I don't know, I feel like my can't pick up. So, if we are talking technically, and I guess I can make it a little bit easier if I get one of the normal stacks of Post-its. Technically, does one piece of paper have a volume?
Yeah.
Yes, and I can see that if I wad it up and it doesn't disappear, we've got volume. But when people look at something that looks like it's just in 2 dimensions, sometimes they think like, oh, well, that just has area. No, like, this has a volume too, but when we start talking about 3-dimensional shapes, we're going to talk about the 2-dimensional base of it, and then how many stacks, or what is the distance between the bases. So here's the tricky part. And guys, I'm telling you, from 10 years of doing this, I know this is a trap door. Height, I want you to write on your paper what height actually means is the distance between bases. The height, because it's not always how tall it is. So the height is the distance between bases. So here, if I try to look through my cylinder, I have another circular base at the bottom. So the distance between them, and on this one it's set up nicely. It is how tall it is. It is standing upright. Looks like a soda can or a paint can or whatever you want to say. So our big B is the area of the base. Our H, our height, is the distance between. Max, you with me? Because I know you went to the bathroom for a minute.
I'm a bit confused. For the one, I'm in the future, so it's the one below this.
Yeah, get out of the future. So big B, if I were to highlight, because we'll do that one together, but after we practice a couple. So that is going to end up being big B, and they calculate it over here, because to find the area of a circle, which you guys should have learned last year, but if you didn't, thanks COVID, we do pi times radius squared, or you could write it radius squared times pi. So area of a circle here for big B in this situation, guys, big B is not always a circle. It is whatever shape is at the base of the shape, of the 3-dimensional shape. So big B is radius squared times pi in this situation. But that's for volume.
Okay, that's what I was thinking. Because I heard the diameter is half of.
Diameter is double the radius.
Yeah, diameter is double the radius, or you can say radius is half the diameter. Goes both ways.
I have this weird thing in my head of finding out that, because I think pi r squared, and you say it past
Pi's r squared.
Pi's r squared.
And they're not.
I know.
Unless you go to the weird pizza shop.
Yeah.
Alright, so. Yes.
So, it would, after you find the area of the circle, would you do times 5, 15?
Yes, we're going to practice a couple of these. So don't worry, this is brand new to you.
So, okay, I don't know if this is going to be but like Max was saying, for the next question, is surfacing that?
I am not answering anything that is beyond the question that is on the board, which is number 18. Notice that you are 5 questions in the future. We are going to look at making some gym bags. If you want to say Phoenix or if you want to say CPM, I don't care who's making the gym bags, but we need some graph paper out.
We actually?
I mean, we could. So right now, 8th grade just actually got approval to get like a t-shirt press, like a heat press sort of thing, so we'll be able to make t-shirts, t-shirts and sweatshirts and stuff like that. So we, the CPM Sports Company, is planning a new line of gym bags. The outside of the bag, without the ends, will be made with a rectangular piece of cloth. Then the ends would have to be like sewn on, right? Because it's got to have like that weird shape of it. Otherwise, the net of the shape would be... So guys, I have these shapes up here that you can come play with whenever you want. and it helps us visualize things. So we're talking about a rectangular prism for our gym bag. And if I want the fabric to all, not actually whenever you want, so sit down. You like to take my words literally, and it's funny, but sit down. So the middle part of the gym bag is going to be this big rectangular piece of fabric, cloth, whatever you want to say. The ends will be their own separate squares that we'll look at just separately. So they tell us
lies about being able to play with things when they
rectangular piece of cloth that is 40 inches by 52 inches. So they show us that down here. Can we what? I mean, you don't really need to make it to scale, but you can if you want to. We're gonna have to solve it. Do you have to? I mean, I haven't even. I'm halfway through asking the question, and I keep getting interrupted. So, if this, dude, come back at math lunch or AO or extensions. But right now, I got a lesson to teach.
Nah. Oh, it is plastic. Ooh, it's plastic.
Plastic kills turtles, Max.
That's the point. They're slow and
Plastic or turtles? Okay, so if this is the rectangular piece of cloth, I want you and your team to figure out how can we determine the amount of cloth or fabric, whatever you want to call it, we need for the entire, including the ends, gym bag. Go. The ends are squares. Okay, the ends are squares. Have at it.
Can I use the
Is
shape?
this what? No, what's your question? No, work with your team.
Look. See
No, you don't.
See how this is 40 inches? See how this other side's 52? 52 square.
That makes no sense. I know, but if the 40 is like centimeters, it's going to be the
This
No,
is
40's here.
Wait, it's what?
That's 52.
That's a really bad design.
Here, sit. Everybody sit down. Sit. Nope. Sit down.
I can prove my opinion.
All right. I have a concern that we are misunderstanding this question because y'all. I apologize. You just came from a practice test, whatever, but I can't fix that for you. The 40 is 40 inches when I fold up the bag. It is 40 inches. The 52 is when I unfold the fabric from the bag. This is 52. Yeah, I know. I got interrupted 5 times during the setup, and it was very hard for me to explain the problem to you.
Wait, what?
So this is the entire piece of the rectangular cloth that is the outside of the bag, not counting the ends. So, all right, this is not how I wanted the lesson to go, but screw it, who cares? So this would be seamed, right? There would be seams or folds or bends across the bag because we unfold it. So then the square on the end is going to use those broken up lengths to make the square on the end. So, Maddie, do you got any information about the square that you want to share? Yeah, the end pieces. So if I... And if not, you can skip. It's totally fine. Jordan? Anything to tell me about the square, about this end? What about it? Why?
Because
We have to do the 52 divided by 4. Yeah, I know. I'm not perfect. I'm not a robot, as I have to prove to Google every day. So, they are equal because now I marked them equal, meaning this is 13, this is 13, this is 13, and this is 13.
But that's just because 14 is always the one.
Hey, can you math today or not? If we can't math today, that's okay. But you need to decide, are we in it or not? Are we doing this, or are we just going to be nitpicky and try to mess my lesson up? Because I got stuff to teach.
I'll be good.
Okay, thank you. I appreciate that. Jake, thank you for raising your hand.
This seems like a very large bag.
I mean, 40 inches is only a little over your... Dude, my swim bag was huge. My tennis bag fit tennis rackets inside of it. When you, like, come, I've seen you in your sports bags. You look like a turtle when you walk into school because you got multiple bags on. This is a duffel bag, man. And actually, 13 inches is not that big for, like, how big your bag is gonna be. 40 inches is kind of long, I guess, for a bag.
No, I thought it was like a 40 by 52, like the size of the
No, that's why we're looking at this being 13, 13, 13, and 13. So, if you haven't already, figure out the total fabric we need. Take like a minute. So I think too many of you were trying to be goofy and pick on me, make you feel bad. Oh my gosh.
Wow. It's my special ability.
Maybe Snap's here.
Wait. So, Lily, did you guys do 40 by 52 yet?
Yeah.
What'd you get?
So 40 by 52. I did right.
Multiply it really fast. Like 40 by 52.
28. Oh, thank you.
2080. Crap, I don't want to write some more. There you go. 28, 2080. What's our label on that? Yeah, because they were giving us inches. 2080 inches squared.
Is it squared inches or inches?
Either. You can say square inches or you can say inches squared. It means the same thing. So then, Nolan, what about the ends of the bag?
The ends of the bag, I'm just solving the area of the total amount of fabric right now.
Well, let's break it apart, because to get to the total amount...
It's gonna need 169.
Yeah, so each end is going to be 160. But how many ends do we have?
2.
2, because every prism... Guys, every... Max, you with me? Every prism has two identical bases. The base of this prism, how we're looking at it, is not the bottom. How we're looking at this prism, we're calling this the base. And this is all the other fabric. So this base of 169 inches squared, there are 2 of them. So there's also one over here on the other end of the bag. That would also be another 169. So how we can solve surface area, I don't have good space to write, but it's 2 times the big B plus LA. What does LA mean? No, lateral area. Guys, sorry, earlier in the year, you're cute. At this point in the year, I'm trying to teach you stuff that you need to know in like 2 weeks, and I'm kind of like running out of time. So trying to be funny is just getting in the way. I'm sorry, but like I got stuff to do. LA means lateral area, which is the area all the way around the shape. It's essentially everything, not counting the bases. So in a cylinder, so we're going to turn the bag into a cylinder. Instead, we're going to see, does this help us use any less fabric? So, with our cylinder bag, where's the other dimension? I think we need to just move on. Because I'm at a loss for finding the other important piece of... Because we got to figure out what this is, right? Yeah, we either need the diameter or the radius.
Why don't we just do 8.5?
No, because that's... I mean, that's saying if you use a piece of paper, if we took a piece of, like, physical paper. Nevin?
I can find the radius and diameter. Yeah.
Did they... How? Because did they say they're going to be equal to each other or what?
Yeah, only reason is because if we're using the same piece of cloth and we turn it into a circle and 40 inches is up and down, then the circumference of the circle is 52. If this is a piece of cloth and this is 40 inches, this is 52 inches, you turn it into a circle. I'm sorry, I have bad circle making skills. This is still 52.
Ah.
Yeah, I didn't think of that.
It's actually
That's genius.
So, wait, for those of us that didn't understand what Nevin said, because the first time he said it, I did not.
He's a smarty pants.
The 52 was the distance around the end of the bag. 52. So what Nevin is saying is if we take the folds out of the bag and just wrap it circularly, the 52 is now the around the what do we call the around? The circumference. So brilliant. If the circumference is 52, what is circumference equal to? Pi dough. Right? Crust is pi dough.
Oh, I was like, what?
So how do I get just diameter? Divide by pi. So what's 52 divided by pi?
16.5521.
irrational number.
So then, to get the radius,
Square root of it.
ooh, divide by 2.
Oh.
So
I was just testing.
8.27.
Yeah,
It's 8.2757.
Nice. All right. So if Nevin, because he figured out he read more than I did. Because quite frankly, guys, I'm a little behind. Like even on my planning and everything else. If this is the same piece of fabric, this is the same. What we should figure out is the base areas, right? Which were 169. Let's see if this is smaller or bigger. How do I find area of a circle? Pi times radius squared, or radius squared times pi. So, just if you've still got this number in your calculator, just hit squared.
It's less.
How would it be less?
I mean, do the math. I don't. You're asking me a question I haven't even gotten to the answer of. So 52 divided by pi
It's 8 to 8, not 7.
divided by 2. 8.276 if you want to be accurate here, because I used the physical pi button. And then that squared times pi gets 215.17 inches squared. So, wait a minute. Which bag would use less fabric? That's for one of the circles. Compared to one of the squares. The circular bag is going to end up using more fabric because apparently if I make this end into a circle, it's going to be bigger.
Oh, that makes sense though.
That
You literally just drew it. It would make sense if you actually drew it like to the scale size. It makes more sense. Can you write down the equation work? You gotta go around the corners to fit. Oh yeah,
That's cool that it works though.
So apparently if we make the bag into a circular duffel, it's going to use more fabric.
So don't make it into
But will any other thing of the bag change aside from just surface area?
How big it is in the middle.
What'd you say, Gus? What do we call area inside? The volume. So guys, give me your eyes. Including Max. I'm about to change where you sit, because half the time you're not looking up at me, because I think you're sitting like awkward and it's hard to look up here. Volume, as we just discussed at the beginning of your notes, is big B, the base area times the height, which is the distance between the bases. Both of our bags are using the same height, right? 40 inches between the bases. 40 inches between the bases. So if this bag has a big B of 169 and this bag has a big B of 215, which one will have a bigger volume? The circle bag. Or we should say cylinder. But this 215 times 40, this is going to be bigger. So sure, it uses more fabric, but the bag is bigger, like on the inside. Max?
I just want to say, I do actually think the cube would be bigger.
The cube would be better.
Better and bigger. Not because it is, like, theoretically, but the give.
So, could you imagine having a bag that is a cube, though?
Yeah.
That, like, what could be a disadvantage, potentially, of a bag that is a cube?
Hard to carry.
It's a little awkward. Like, scale this up and, like, put a cube on your back. Or put a cube
Is
on
it
your...
going to be made of solid plastic?
Well, I mean, what's inside of it might be solid. You know what I mean? Once I pack it full of my stuff.
Well, I mean, if you're going to cross a baseball bat and then
I have one. They're very annoying.
Well, and so,
I have
if
the same exact bag.
if I need to fit a baseball bat in it, does a cube make more sense than a rectangular prism? Probably not,
Not a
because
cube,
this is
a
longer.
prism, yeah.
You said cube.
I meant,
Oh, you meant prism. Sorry, you said cube. Sorry.
You meant
Cube means all the lengths are the
A
same.
cube would be a purse.
A cube could be a purse, yes.
Wait,
You don't know what size my purse is.
Max.
It's like,
I have a man wallet. Yeah, not my man.
Everyone needs a nurse. It's a man purse.
Exactly.
Or a male nurse. Is a nurse. Alright, so with your group, find the surface area and volume of this. And if you think, wait, we don't know what we're doing, good, try it. Figure out what you struggle with.
It's on the homework.
This is on your homework paper. Now you may go to that point that was a few
it's present. Huh?
It was Cecil's bag. You're trying to figure out.
Cecil, we're going tightrope walking.
Oh my god, Cecil was the best. I hated Cecil. No, I didn't mind. Either you hated Cecil or not.
I can't say it.
That was really
Ah! There's a snake!
Oh.
Oh my god.
Because that was what we were supposed to do. I just couldn't. My brain was glitching out. How'd you figure that out? I'm running block. Wait, so if I had read the directions. Oh, directions. Curses directions. Ah, yeah, your mom texted me about that. She's like, don't worry, it's after math class.
It's like, I was like right at the transition.
Hey, can we stop singing a song that has nothing to do with what we're doing right now? Because all that means to me is you're not doing what I'm asking you to do. So if you are color coding, big B is going to be a circle again because we're working with a cylinder. So because it's a cylinder, we know big B is a circle. Anna, what is the circle area formula? Radius squared times pi, which I love because radius squared is the math I actually have to think about. Now wait. Did they give us the radius?
Oh my god, it's 5.
Yeah, so did they give us the radius? Kind of. Right? Like Anna said, we can just divide the diameter by 2 and get that the radius is 5.
Oh my god, it's 5?
Hey guys, especially if you're not comfortable with this yet, you should always start by writing out the formula for whatever shape you're dealing with. So here, area, and we could say big B, but I'm just going to write I already wrote the A before I thought about big B. So it's radius squared times pi. Then we fill in the radius, Anna just found, is 5, so we square that. What's 5 squared? 25 times pi. You have a pi button in your calculator that will get you a more accurate answer than just using 3.14, but you may use either unless I tell you exactly which one to use. 78.5. Was that using pi button or 3.14? Okay, so you said 78.5? Centimeters squared. Max, you got the stuff written down on your paper? Because you're going to need it before you leave the room. This whole problem, you already did. You got that big B with 78.5? Well, I don't know. I'm not there yet. The volume equals what?
No.
So, hey, I got it. Remember, I'm the teacher. I do not believe that you have this work written down. Please check your paper. I shouldn't need. If you just told me the volume's 120, that is incorrect. So I need you to cross.
Is that base or
That is
So,
surface.
I need you to focus and stop getting out of your seat to play with the shapes.
You have to do volume and surface area. I didn't know how to do the surface area.
This is not big B. This 10 is the diameter of the circle. We use that to find the big B, which we find is 78.5. We're not even doing surface area yet. We're just trying to do area of the circle. Does finding the area of this circle make sense to people?
Yes.
Kinda.
Then, because I'm going to walk around and check people's papers, we need to find the circumference, because when we go to unwrap the circle to look at the rectangle, that is our lateral area, right? We said the lateral area, the area around the cylinder, will be that circumference times the height. The lateral area is going to be our circumference times our height. Set up the area on the board. Right, A equals either r squared pi or pi. So then, the radius is half the diameter. So the diameter and the radius is 2. So we have the work of equals pi squared by 2. We actually get to 78.
What'd you get from like volume?
That is our big B. That we then have stacks, and I have pancakes or pennies or whatever you want, that are 12 stacks of volume. Right, so we're going to take that times 12 to get the volume. Okay, so volume is easier than surface area. I like to start with volume. So either grab a calculator or ask one of your buddies what that times 12 is. But I would write out in Word that volume equals 12. Hey, you can take whichever route you want. I think volume is easier, so I start with it because it makes me feel good. What? Come on.
You go inflation before you go deflation.
Yeah, ego inflation first. So, volume is the big B, and I can imagine, if I can see through this shape, I'm bad at this, I have a circle back here, and then it stacks up times 12. So to do volume, I'm going to do the 78.5 times 12. Get that? Anyone got it for me? 942 point what?
4, 7.
My brain can only remember so many numbers at a time.
Or you could do.
I just did 4, 7.
It's just
I
not.
rounded it up.
Centimeters cubed, because we're talking about volume.
I only got 9.2.
Hey, I need us all, I'm sorry, but we need to focus and no off-task talking for like 2 minutes because I got to wrap up this lesson. I got to bring it full circle. To do the lateral area, I need to imagine unrolling this entire circle. So imagine that I cut it and then I unroll it. The length of it will be the circumference, and then it is 12 centimeters wide. So to find the circumference, I do pi times the diameter, which is pi times 10, which is 31.4 approximately. That I will multiply by the height, and that gets the rectangle that rolls up to make that cylinder. Like if you've ever cut apart a pop can, it's dangerous, by the way, or anything, you know that a cylinder can unroll into a rectangle. So this lateral area is that rectangle. What's 31.4 times 12?
376.8.
It was 99.
Yeah, it's 99.
What?
You can do 376.
It probably depends on if we use 31.4 or the more precise. Hey, so especially if you're working with each other, your answers should just be close to each other. If they're slightly off, that's fine. It's pi's fault. It's pi's fault. Jordan? Correct. Diameter is different than radius squared. So down here, pi times diameter uses 10, not 25. Did I make a mistake somewhere or what? The circumference is 31.4. The circumference is 31.4. If you do not believe that, you probably need to come work circles with me. Because the diameter is 10. 10 times pi is 31.4 approximately. This is rounded. So then, to the lateral area, how many bases do I need to add to it? How many circles do I have? 2. So with that lateral area, I need to then add 2b, 2 of the bases. So notice that most of this homework is volume, volume, volume. Most of this homework is reinforcing volume, which is right here. Surface area, we will do more with tomorrow. I don't actually think I asked you any surface area problems on this homework. Volume is easier. Doesn't mean it's easy, but it is big B times the height. Height's distance between bases. Big B is the base area. That's all that we got time for. That's all, folks.
Okay, but
I was like, what? I was like,
Hold on, let me stop recording so our little math argument